Okay, so we're going to talk today about how to identify and perform dilations. So that's our first learning goal, is I can identify and perform dilations. Second thing is I can solve real-life problems involving scale factors and dilations. I'm going to skip past that. Okay, so a dilation is a transformation. You may or may not remember, but last year you went through a bunch of transformations like a translation, reflection, or a rotation. Those are what we call rigid transformations. They don't change the shape or the size. A dilation is a little bit different. So a dilation is a transformation that enlarges or reduces a figure, and you do it with respect to a certain point. In this case, usually in this book, they label it C because it's called the center of dilation. And you'll also have a scale factor K. And it'll probably be easiest to show you an example of kind of what this looks like. So let's say I have this polygon right here, and I want to dilate it. So there's two things I have to have. I have to choose a center of dilation, and I have to choose a scale factor. So let's say the center of dilation, I'm going to put it right here at that point at 0, 2. So this is C, my center of dilation. And let's call the scale factor, let's make it easy and just make it 2. Okay, what I do then is I look at this, I want to make the distance from the center dilation to each of these vertices. Let's number off the vertices. Let's call this A, B, we'll use D down here since we already used C up there. So I want to measure that distance. I want to go twice as far. So what I mean by that is I go from my center of dilation, say how far is it to E? Well, to get there, I had to go down 1 and over 1. So if my scale factor is 2, I'm going to go twice as far. So I'm going to go down 2. Just erase that from there. So I'm going to go down 2 and over 2. So instead of going down 1 over 1, down 2 over 2. Okay, there is my new point E. So that's E prime. If I measure over to A, it's going over 2 and up 1, right? Over 2 and up 1. So I have to double that. My scale factor is 2, so I have to go over 4 and up 2. There's my new point A right up there. When we label that new point, we say it's A prime. It's just an A with a little tick mark by it. You may remember that from last year. To go to D, I'm going down 1, 2, 3, and over 2. So I've got to double that, so I'm going down 6 and over 4. There's my new point D, D prime. And for B, B is just horizontally 1, 1, 2, 3, 4. So I'm going to double that and go 8. So 5, 6, 7, 8. There's my new point B right there is B prime. Okay, let's connect those points. So I'm going to grab a straight edge. If you're making it there too, you can grab a straight edge, connect. I can't do the straight edge, but you guys can. Connect those points. And what should happen is you should end up with the same shape. It's just a different size. So if you look what it is, it's the same shape, but this has been enlarged by a factor of 2. If we were to measure the distance, so let's look at some corresponding sides. Let's say I looked from A to E and measure that distance. If I measure the distance from A prime to E prime, it should be the length should be double because my scale factor was 2. Or if I pick any other side, right? If I measure from A to B, if I measure from A prime to B prime, that distance is going to be double that. Okay. So the scale factor is just going to, if it's greater than 1, it's going to enlarge the shape. If it's less than 1, it's going to shrink the shape. Let's go down here. Let's do another one. This is the same shape. But this time, let's make the center dilation at 0, 0. In your book, on all the problems you do, if it just says to dilate it, then you always assume the center of dilation is at 0, 0. If it's going to be anywhere else, it's going to tell you. Okay, so I have the same points. I have point A, B, D, and E. And this time, let's do a scale factor of, let's do a scale factor of 1/2 and see what happens. Okay, so I start from my center of dilation. In the original shape, I go over 1 and up 1 to get to E. So if I'm times that by a half, I'm going to go over a half, and up a half. Let's put my point E. Let me do a different color here. We'll do an orange. So my new point E is going to be right there. All right, go to A. So to go to A, I'm going over 2 and up 3. So I'm going to go over 1 and up 1.5. Somewhere in there. There's my new point A. If I go to D, normally it goes over 2 and down 1. So I'm going to go over 1 and down a half. There's my new D. And if I go over to B, it goes over 4. So I'm just going to go over 2. I'm going to cut that in half. So I just take all those distance and cut it in half. Now when I form that shape again, what we should see is a similar shape. Right? What I mean by similar is it has the same shape. It's proportional. It's just a reduce now. It's a reduction instead of an enlargement like the last one. So really quick, this is pretty easy. If your scale factor is greater than 1, it's going to enlarge it. If it's less than 1, it's going to shrink it. Something else I want to show you is if you line up the vertices, like if I go from the center dilation out through B, you'll notice that it runs right through, that the vertices that correspond go together. Right? If I go out through A, I go out through D, you'll notice how all those vertices are all lined up right there. Okay, so a couple important facts. Scale factor, greater than 1 is going to enlarge it, less than 1 is going to shrink it. Something else that's kind of cool and really easy is if you look at, let me show you one more example with this one. If you look at this same problem, but let's do a scale factor of 2 again, just because it's really easy to do and to see. So if I double those distances, the F is over 1 up 1, so I'm going to go over 2 up 2. This is the new F prime. A is over 2 and up 3, so I'm going to go over 4 and up 6. That's all the way up here at the top. Then go to D is over 2 down 1, so I'm going to go over 4 and down 2. And then to B it's over 4, so I'm going to go over 8. All the way over there. And again, we know what's going to happen. I have the same shape, right? I've got the same shape. It's just enlarged by a factor of 2. Let me look at it. Sorry, that wasn't very straight. But what I want to point out is the points. I want you to compare these points. So if you look at point A, the coordinates of point A were 2, 3. If you look at A prime, the coordinates end up being 4, 6. Then let's look at B. The coordinates of B were, 4, 0. The coordinates of B prime are 8, 0. If you look at F, the coordinates are 1, 1. The coordinates of F prime are 2, 2. So what's happening is, and this only works if your center of dilation is at 0, 0. But lucky for us on this assignment, in this book, it's almost always going to be. In fact, I think it always is. What happens is there's a shortcut way of finding your points, and that is, if your scale factor is 2, I just take both my x and my y coordinate, right, the 2 and the 3, and I just times them by 2, right? I end up with 4, 6. You know, my point was 4, 0. I times them both by 2, I end up with 8, 0. Or 1, 1, I times them by 2, I end up with 2, 2. So if your center of dilation is at the center, you can just take your scale factor and you can just multiply it by your coordinates and you get your new coordinates that go with it. This one's a little backwards. This one has the two shapes, and you're going to find the center of dilation. So where's the point C at? And you're going to find the scale factor. You're going to find out what K is equal to. Well, we talked about how you have these points that correspond, like those 2 points go together. If I draw the line that passes through there, and I do this for all the points, so I'm not going to pick these 2 points and draw the line that passes through those 2. I can go straight here. If you use a straight edge, it's even easier to see it. Yeah, I got these 2 points up here. But if I draw the line straight through all those points, what we should end up seeing is that they all meet at a single point. And that point right there is your center of dilation. So for this shape, the center of dilation was at 0, 1. And then if you want to find scale factor, we can do one of two things. We can compare the distances. And what I mean by that is I can come down here and say this one goes, I go down 1 and over 1 to get to there, to this point. And then compare that to the other point. I go down 1, 2, 3, 4, and over 2 to get to this point. All right, so I went down 1, over 1. This one went down 4 and over 2. Well, my scale factor, if it's an enlargement, then it has to be greater than 1. So I'd say if it was an enlargement, if I was going from the little one to the big one, I'd go 4 over 2. If I'm going from the big one to the little one, then I go 2 over 4 because it would be a reduction. So you have to decide when you decide the scale factor, like what's my original shape? So let's say this was the original shape. I'm going from the blue shape to the black one. That's a reduction. So my scale factor would be the 2 over 4, which is a half. Okay, is what my scale factor would come out to be. So if you're given a drawing, you can find the center of dilation and you can find the scale factor. That's most of what you're doing here. There's a couple of application stuffs like this where it says find the scale factor of the dilation. It's really important to recognize which is the original point and which is the new one. So this one says it's point P, it's the original one. So that distance is the original. And this is the P prime right there. So that distance is the new one. So you have to decide if it's an enlargement or a reduction. Well, this one's going from P to P prime is getting bigger, so it's an enlargement. So when I pick my two numbers, I can either go 8 over 12 or 12 over 8. Well, because it's an enlargement, I'm going to pick that one. When you write the scale factor, you can write it as a fraction, but we ought to reduce it. That'd be what, 3 halves? Or you could write it as a decimal, be 1.5. Or if you want to write it as a percent even, you can write it as a percent, 150%. I'll look at this next one. On this one, the point P is the original one. So this is the original shape right there. And the new P prime is a reduction. It's getting smaller. So again, my choice is I can either go 30 over 18 or I can go 18 over 30. Well, this one, because my new point, my new shape, this one right here is the new one. It's a reduction. I'm going to pick the number less than 1. So my scale factor is going to be 18 over 30. Well, you can divide both of those by 6, I think. You get 3/5. If you want to write it as 0.6, you could, or you could write it as 60%. Like any one of those would be all right. That's really most of what's on the assignment. You have to be able to do a dilation, plot points and do a dilation. You have to be able to find scale factor. Here's another one. It says in a dilation, the CP prime, that just means, right, C is the center of dilation, and P prime is my new point, is equal to 3. And then from the center of dilation, right, from the center to the new point is 12. So you got to decide if it's an enlargement or a reduction. Well, if this is the original, right, this is the new one because it has the prime mark. So I'm going from 12 to 3. So this one is a reduction. So I'm going to just compare those lengths. I'm going to go 3 over 12. So that will be, scale factor would be 1/4 is what it'd come out to be. The only other thing here, really, this is what we already talked about, right? Where if the center dilation is at 0, 0, I can just times my coordinates by K, by the scale factor, and I'll have my new points. That's as long as the center dilation is at 0, 0. That's important. It has to be there. Really, the only other thing I had left here was this is one where you plot the points and then you do the scale factor. That's similar to what we just did. There is this application problems. It isn't a lot different. Let's do this one. It says you're using a magnifying glass that shows the image of an object that is 6 times the object's actual size. Determine the length of the object. So this is the actual, determine the length of the object, the image of the spider you see through the magnifying glass. So the original one is 1.5 centimeters. So if I get the magnifying glass that shows the object, it says 6 times the original size, how big would the object be in the magnifying glass? Like, this isn't hard, right? I just take the length, the 1.5 centimeters, and I multiply that by 6, right? So 1.5 times 6, so that comes out to be what, 9? So if I'm looking through the magnifying glass, that object would be 9 centimeters long. But that's pretty much all it is to it. You need to be able to perform a dilation, right? Remember our learning goals up at the top up here. We want to be able to, identify and perform dilations, I think we covered that, and we can do that. And then just some pretty, not too hard, just some pretty simple problems where you're using scale factors and dilations and applying to real life, like that magnifying glass problem we did right there. I mean, that should be everything. Good luck.